What I want you to do is individually, there's no writing involved in this. I want you to think through this histogram here, kind of a horizontal histogram. What's going on, and answer these two questions. What do you notice about this data? What conclusions can you draw? Similar questions. Come up with one or two things that stand out to you or you learn from this data that's presented to you. And then I'll give you some time to share within your group, and then I'll call on some people to share out. For the most part, this section is very vocab heavy and is our focus. So the first one is our modes. And so it's talking about really four main definitions. We have uniform, which you can see in the third picture there. And uniform is kind of a straight across. Hey, the data is all about the same level. It's pretty uniform. All looks about the same. And then we have unimodal. What's uni mean? One. So we have one peak here. So that's unimodal. Bimodal. Bi means two. So in this case, we have two peaks of data. And then we have multimodal. Multi means many, multiple. And so we have multiple peaks here. Now, technically, bimodal is multimodal because it's more than one, so it's many or multiple. But bimodal is a more correct description of that. It's kind of like when we're doing polynomials, right? We could call it a quadratic polynomial, but it's more descriptive to call it a quadratic, gives us more information. Same thing here. Of descriptors. So as I look at this one here, unimodal is kind of our normal distribution. I draw a center line there. We have kind of even distribution of data on both sides. If I look at bimodal, does that center describe a lot of what's going on in that data? No, there's hardly any. So sometimes center is not always the best descriptor of what's going on. Kind of depends on what your data is. Now in uniform, it wouldn't be so bad, but you just have not a lot, but at least it's evenly distributed across the board. All right, so here's what we're going to do now. Each group. All right, next one is talking about skewed distribution. It's when most of the data is to one side, leaving the other with a tail. So as we look at this here, first one is the easiest one to make sense, is symmetrical. So symmetrical is the easiest. Most of us know the definition. Symmetry, kind of mirrored. I can draw a line down the middle, fold in half. Now, with this, the data doesn't have to be perfectly symmetrical for us to call it symmetric. This one here, you can see it's not quite perfect, but it's pretty close that we can identify a center that would be mirrored both ways. Now, left skewed and right skewed to me is where this can be a little confusing. Okay, what we have here is left skewed is kind of opposite of what you would think. Most of our data is to the right, but we say it's left skewed because that's what they call the tail. That's where it tails off to. And so where your tail goes is where what they call left skewed. So most of my data is over here to the right, but my tail goes this way, so it's a left skewed that way. And then same thing for the right. Most of my data is here, and then it skews off to the right that way. Okay, next one here is fairly simple to figure out. So what I'm going to let you do is I'm going to let you take a look at those pictures, the diagrams, and then also the definition. I want you to come up with your own explanation, and then I'll call on someone to share out. Okay, so a point that's kind of off by itself. So example Matthew gave was a really high number, and then one high number, and the rest is a bunch of low numbers, kind of off by itself. Outlier, one of my classes we went to Animal Kingdom and talked about the lone wolf. And so the lone wolf who doesn't run with the pack, they're off by themselves. And my last period decided to get emotional analysis and said that they're just sad and lonely. So, but outlier is probably the easiest one that you can see and identifying this because it's very obvious. They're be data. Sometimes it's more than just one. Sometimes maybe one or two, but are definitely separated from the majority of the data. All right, same thing with this one. Fairly easy to understand, so I'm going to give you a little time. Think through this one, kind of come up with your own description of what normal distribution is. So having those equal to each other, mean, very close, may not be exact. Could be, hey, my mean's 14.1, my median's 15. So our central tendencies are really closely located to each other. And then about even distribution. Now, surprisingly, that's why it's called normal, this type of distribution happens quite a bit through a lot of different things, nature, all that stuff. That's why it's called the normal distribution. It's pretty normal to see, even though it would be a little different. Now, how many of you guys have ever heard of a bell curve, especially in particular to grades? Hey, do you know how bell curves work? And you do? Do you know why you probably should not ask for one? So let me explain this to you. I think this is an interesting fact. So the reason this is called the bell curve is if I kind of trace this, kind of gives the old traditional bell look. Well, the way a bell curve works for grades is it gets split up into 5 sections. So when we did the box and whisker, we had quartiles. It was 4 sections. This one gets broken into 5. And the way this works is this is your A's, your B's, your C's, your D's, and your F's. And what they do, they assign a percentage of the student body to each of those categories. Generally, what you'll see is your A's and F's get 5%. So, good news is likelihood of getting an F is pretty low. Bad news is likelihood of getting an A, also very low. D's range, but what I had as a professor once is 10%. Sometimes you'll see 15%. They can vary it how they want to a little bit, but this is kind of the general. And then C's are at 70%. Now let's put this in perspective for you. So currently in our class we have 6, 7, 11, 16, 19, 22. So let's round it to 20. All right, so we have 20 students in this class essentially. So what is 10% of 20? 2. So what's 5% of 20? 1. All right, so let's do this. Maya, stand up for me. Hey?
Yes, Maya.
Maya, you got an A. You're the only person in this class who gets an A. Because you're the... Okay? Huh? Sit down. Thank you. Kylie, stand up for me. Now, this is no reflection of actual grades, but let me put that disclaimer out there. Kylie is our sole F. Congratulations. All right, now, Parker and Cameron, stand up for me. You guys are 2 B students. Good job. You can sit back down. Hank and Jeremy, stand up for me. You guys now are our 2 D students. Okay? Go and sit down. The rest of you, stand up. You guys are all the C students. So there's a lot of you there. Now, you can go sit down. Now you think, I like these odds. Hey, at least I get a C, I pass the class. In some classes, it's not such a bad idea because some classes are ridiculously hard and you're like, I just want to see so I can pass this class and graduate. Now, here's where this can kind of suck. Okay, let's say Maya got our sole A, but she has a 98% in the class. All right? Parker and Cameron were our B's. Parker's sitting at a 97%. Cameron's sitting at a 93%. This is B. Based on a regular scale, that would be an A. Based on a bell curve, you just got what in the class? You got a B. Take it one step further. Okay? Juan was one of our C students. He's right after Cameron and has a 91 in the class. Okay? It's an A based on a regular scale. but based on a bell curve, you now just got a C. So sometimes it's not always the best to get a bell curve, because what they do is they take all the data, so all the grades, and line them out from highest to lowest. And they go 5%, 10%, 70%, 10%, 5%. So most of you are going to end up at C's, even though maybe the work you did was A percentage work. Correct. Whatever her grade is, if it's the lowest, she would get an F. If everybody in the class, percentage-wise, had a 90 or higher, and say she's in a 90.1, but she ends up being the lowest one, under a bell curve, she would have an F. So a bell curve is not always something you want to ask for, because you may get what you want, or you may get what you ask for, but not what you want. Okay, most of you, when you ask for a curve, last one here is what we call variability. All variability talks about kind of how spread out the data is. It's kind of the idea of range when we talk about the range of a graph. Okay, so if there's a huge range, we say it has a high variability. That's our outer solid line. And then our small little dots will be our low variability. The data, there's not a whole lot of difference between our lowest and highest value. All right, and then center is kind of, we're looking at the center of our data. Sometimes that's a good description, as in a normal distribution, because most of our data is in the middle and it describes most of what's going on. We have symmetry. But if you look at, say, bimodal, which I'll go back to here, that one is not. Here's what we need from 8.1. So yesterday, we created a histogram and pasted it into your notes. What I want you to do is that you're going to copy that histogram, paste it in here, and then using the vocab that we just got done talking about, which I also attached as the words of the day, using those, I want you to describe the data and distribution of the histogram that we created from yesterday's texting lesson. All right, so group 8, give me one descriptor that you guys use for this one. Okay, it's skewed right. And why do you say it's skewed right?
There is an outlier way out there. Most of the peaks are to the left.
Yeah, if we kind of look at it, our data, that one's a little bit lower, but we get the general idea here. Right, so that one should be a little bit lower, but as we go, kind of goes more like that, right? Okay, so our tail is to the right, so we would say we're skewed right. Good. All right, group 7. What's another descriptor you used?
I said it seemed like it could be multimodal.
Okay, why multimodal?
Oh, because if you were to trace it, it'd have about 3 peaks, even though the one to the very right is smaller. It would be a little higher than that gap. It would have like 1, 2, 3.
Okay, I would say using that outlier there is probably stretching it for a peak.
Yeah? Alright then.
Let's think in terms of mountain ranges and not anthills.
Okay.
All right, so if I can step on and crush it with my boot, I'm not going to call it a peak. So with that described, you would say it's what? Not multi, but?
Bimodal?
Bimodal. Good. And last one, group 2. Is there another descriptor you can add to this? It does have an outlier, and how do you identify the outlier? Yeah, this one all the way out here is kind of totally off by itself. Good. Next thing. So we didn't quite get to finish this, so on your notes, it's already done for you. So what I want you to do on the 8.1 notes, if you go to the second to last slide, there is a box and whisker plot of the text data. What I want you to do is I want you to screenshot it, and then you're going to paste it in here and then do the same descriptor that we just did for the histogram. Remember to screenshot, Control, Shift, and then it's the button right above the 6. It looks like a rectangle with 2 vertical lines. It's the window selector button, if you want the official word for it. Of this one, should be fairly same as what we just got done doing. Now, as you look at the box and whisker of this, it's a little harder to identify your mode because you don't see peaks and valleys in a box and whisker. So that's one of the things to recognize through this. We can still be skewed left. Okay, so that data comes down as we're looking at that.
Wait, why is it skewed left?
Because as we look here, and then we have that tail going off to the left.
Wherever the tail is longer is where it's skewed.
Yeah, and this is the one I was back there talking with Elliot. This is the one that confuses me the most, and I have to go back and forth. Like we had a discussion, I said it was skewed right at first, because the definition to me is where most of the data is, and so part of me would say most of the data is here to the right. So we'll go from there. And I may come back on Monday and fix it once I wrap my head around it a little bit more. So we'll see how that goes.
Skewed right, and it's unimodal.
Okay, so we're skewed right. Why is it skewed right?
Because it tapers off to the right.
Yeah, if we kind of drew and traced it, it tapers. We have that slide that goes to the right. Unimodal, good. What else? What about the variability? What would you say? With, I would say low.
Why? Explain.
Low because there's not a huge distance between us.
I see.
It is relative sometimes depending on what you're looking for. But it's about a spread of 40. And I wouldn't say that's a huge gap of area. And everything's kind of, for the most part, decently spread between those.
Makes sense.
Are there any outliers on this one? No. Good. So no outliers. All right. What do you guys got for me? Yeah, you could argue that. I would probably say this is more uniform because a lot of our gaps, there's actually no data in between it. And so I would say this one's more uniform because it's, for the most part, pretty flat across the top. Hey, what else? Outliers. You can say it has semblance of being symmetrical, okay? Because our data is kind of evenly distributed there. Yeah, this is a low variability.
Yeah, I don't get the
Good, so we're skewed right. And why do you say it's skewed right?
Because the middle is more towards the left of the box.
The median?
Median.
Yeah, good. And to help with this, let me jump over to a website that does a good comparison. Thing about that we talked about is we draw our middle. That's kind of to the right of our median, so we skewed right. What else do we know about that one? This one has an outlier. And it's somewhere around 42, 43 in there. What else about it? You could argue that since we already said we had another one that was about the same amount, that we said was low, we'll say this is low relative to other stuff. Because this one goes from 60 to 100, so it's only about a 40. And notice our box is pretty compact. It's not a whole lot of spread on that. Okay, good. And 1D now. Who had 1D? Okay, so unimodal, good. Okay, so no outliers. Okay, symmetrical. What else? Okay, low. I go with that. We can also say that this one almost has a normal distribution. Hey, it kind of fits into that bell curve we were talking about. So it's symmetrical, but it has this nice sloping off to both sides. Not perfect, but fairly close. All right, 1E. Okay, so skewed left. Okay, and again, not by much because there's probably about where our middle is. Okay, but I would still say that it's skewed left.
No outliers.
Okay, good.
Seems to have low variability.
Good. That's about it. It's hard to talk about uni multiple because there's no real peaks that we can see in this data. So that's usually what we can get out of our box and whisker. And last one, 1F.
An outlier.
Okay, so outlier, kind of in the range of 41 to 46. Okay, what else?
Skewed right.
We are skewed which way?
Wait, left.
Skewed left, good. Hey, we kind of have that slope up to there. Hey, what else can we say about it? Unimodal. All right, what else about it?
We're doing low variability.
Yeah, so when we call something outlier, we kind of throw that one data point out. And so if we just look at from there to there, we can say that's low variability.
Or between.
Okay, good. What you're going to be doing from here on out is, so we've talked about all of these that you're going to see on the next couple slides. You're going to go back, look at the descriptions we just put together, and you're going to compare these together. What do they have in common? What are some differences? What is like shared information that they give you? Maybe they have the same variability, but it's definitely a different set of data because one's unimodal, one's normal distribution. Whatever those are, I want you to describe those. Okay, so you have 4 of these to do. On the next 4 slides, I want you to work on those. You have the rest of the period to work through that. And then once you're done with those, you're done with the 8.2 notes and you can go and turn those in.